Yeah, so hi Gaurav,
Hi
welcome
Tejas,
to the channel, and it's absolutely a pleasure to have you here.
thank you so much for inviting. And let me just start by saying that, Tejas, you're doing a really good job in doing this kind of podcast because I think with the semiconductor market booming in India, I think a lot of students from a lot of background will get inspiration to kind of join the VLSI
Mhm.
industry, especially the analog, which is a very niche industry right now in India. So I hope more it reaches out to more people. And thanks for inviting me. It's my pleasure
Okay,
to be here.
thanks for saying that. So, could you give a brief introduction of yourself for the viewers?
Sure.
Like,
So my name is Gaurav Sarkar, and I actually did my bachelor's in 2017 from Institute of Engineering Management, which is a tier 2 college in Kolkata. And after that, I immediately joined for my master's in Texas A&M. So my background was a little bit in like microwave theory and antenna design, and I was never exposed to analog design prior to my masters. So I consider myself fortunate enough to join Texas A&M, which is a really good school for
mhm.
analog design and research, and that's where my analog journey started. Yeah. And I have
Okay,
interned in companies like TI, I worked for ADI, I worked for a startup which was founded by an MIT professor, Dr. Dave Parrott. I was there for a year under his research group, and then I finally joined Renesas in the Smart Power Stage group in Austin. So currently I'm working as a senior designer in Anode. Yeah.
okay, good to know. So, how did you decide, and when did you decide that you want to go for a master's, and how was the process like?
So initially, I had no intention for masters. I was actually thinking of GATE, but I actually interned in IIT Kharagpur during my third semester,
Okay,
and there like I have seen like all the bachelor guys like they were like preparing for like GRE and they're talking about research and all. So for me, it started back then, but I was very much interested in doing like computational electromagnetism actually computational
okay.
EM and working on like cyber physical system because Texas A&M had a very good collaboration with
Mm-hmm.
NI. But when I went there, one of the professors I was supposed to work with actually left the college and went to Penn State.
Oh,
So that's when I decided to like kind of shift my career towards analog. And trust me, it's been one of the best decisions I've taken. When I entered the class, I actually did not know about even current mirrors. Okay, like I just knew PMOS, NMOS, and stuff like that. But in my batch, like I think I was very few people were from my background. Like mostly, I was surrounded by people from like IITs, top IITs and NITs and MITSians. And even those who came from tier 2 colleges, I think they were mostly like they have worked in India in like TI or
yeah,
some.
right. Without any work experience, straight
Yeah,
from your bachelor's.
I joined without any knowledge about analog design. So I took the course at the last moment, and yeah, I think after that it's been a pretty good journey. It's not been an easy journey. It's a very tough subject because I've seen my friends like work in digital VLSI as well.
Mm-hmm.
I feel that field is a little bit more easy to deal with because analog, I think it encapsulates like circuits, signals and systems, control theory, communication,
Yeah,
power. So it goes on and
it's
on, right?
everything. Yeah.
Yeah. So it's very challenging for someone with my background, but luckily I had help, very good, surroundings. So I learned a lot. I had the opportunity to like even like sit with Shantivan's student. His name is Srijish, so he was there in my class. A lot of students from IIT Madras, Ashwin, and they were like excellent. So I learned a lot from them that helped me grow. And I think it's very important that if you're doing masters, there should like during my time there were no such channels or
Mm-hmm.
even in
Yeah.
LinkedIn like very few people were active or would discuss about analog VLSI, right? So right now if you see the trend like everything is there out like in YouTube you'll find like tutorials. You yourself are doing
Yeah,
tutorial
yeah.
videos and I've seen your feed forward composition videos very good. And so there's a lot of resources available. Back then it was not. So, but yeah, I mean, eventually you have to grind through. And I feel that analog is more like based on experience rather than, so it comes with a
Okay.
lot of experience and practice.
Mm-hmm. So you mentioned about GATE and you mentioned about masters abroad, but that means
Yeah.
you never thought of a job right after your bachelor's.
No, I never thought of a job right now because I was never interested in software. Like most of my friends who are doing well, like they ended up in like consultancy, big
Mm-hmm.
consultancy,
Yeah.
because it was everyone knew it was really hard to crack the analog job, right? And even like companies like TI or Qualcomm would come, like there would be like a pool placement, so it was very hard to
Yeah.
kind of crack the written exam first of all, right? And back then, like I had like not much experience, like we didn't have like very good faculty that would like
Hmm.
teach us the really good like analog or circuit analysis. So for me, like the journey started back like in Texas A&M itself, and
Okay. Okay.
yeah,
So usually when people apply for a master's, I think they require like three LORs, a letter of recommendations,
yeah,
and people usually look for like a good research profile.
yeah,
So
yeah,
how
yeah.
did you build those?
So for me, like I think I was very lucky to get into Texas A&M. I don't know how I got in, but for me, like yeah, I had worked for a semester in IIT Kharagpur. I had like done some research over there. I got a reward from the professor, and my GPAs were consistently good.
Yeah.
So that's another thing. Like let the students should not be fooled, especially if you are like from tier 2, tier 3 universities. You need to have like really good GPA so that you can show that like you're a hardworking student. And obviously, research profile is a must. You should do some kind of research just to show your background. Like I said, I went to masters for electromagnetism and had quite a good profile in that. I had like done some research on microstrip patch antenna. I was doing like optimization theory regarding that. I had computational
Hmm.
electromagnetism as well. So I was quite comfortable in my area. But then I switched completely to analog VLSI, which was like
Right.
a big step to me. Yeah. So, but yeah, you have to be prepared. It's not like you have to get good GRE scores. You have to get good TOEFL scores. So those are like a must. And those don't guarantee your admission. Those are just like a
Hmm.
negative filter. If you have like a very less quant score, your application won't be considered. How good you
Right.
are in, yeah. So I think all
That's true.
those things have to be taken into consideration. And back then, I believe if I had been more exposed to the analog industry, right? Like right now, I know that okay, there are so many good schools in India. Like IIT Madras is a top school.
Hmm.
Even in IIT Delhi, we have good professors. Recently, IIT Kanpur is
Yeah.
like ramping up on the analog stuff, and IIT Bombay always had like a good professor. So right now, I know about all those professors
Hmm.
and what all research is going on. Back then, I had not much idea. So pondering now, if given a chance, I might have done a master's in India itself because it's not much different. I feel that here there is like more research opportunity and more exposure, but I feel like even like during my masters, I would watch NPTEL videos from Shanti Pawan, Nagendra
Yeah, those lectures
Kishore.
are pretty good. But the main
Yeah.
difference I think it boils down to is if let's say someone wants to work abroad, then it's easier to, go
Yeah,
for a
I mean
master's and then.
that's obviously that's and I think like the way circuits are analyzed as well is kind of different because I've seen a lot of students who have come from like IITs and ISCs like after their masters they have worked in India for a while and then they have come here, especially in TI.
Hmm.
So I feel that students from India are like more mathematical based. Like they want to analyze
Hmm.
the circuit, they want to do like small signal analysis first, they want to derive the transfer function. They believe less in intuition, which I believe is a big drawback,
Hmm.
especially when like you won't be designing blocks forever. That's like a myth for analog designer. There are so many things to look about. Especially, I feel the most important aspect of an analog designer is like debugging, right? How do you debug someone else's circuit?
Hmm.
So you have to understand why did he design it that way in the first place, and because like all the
Right,
designers
right.
have so the blocks go like modification after modification. So when it comes to
Hmm.
you, you have to understand the whole circuit and its thinking analysis, and that's where I think like practical and intuitive insight works the best rather than just sitting down and trying to do like a complex mathematical modeling or analytical modeling. Yeah.
Right, that's true. I understand. So, okay. And how was your experience at TAMU? So recently, one guy he messaged me. He
Mhm.
got an admit into TAMU,
Yeah.
and his question was that he's also gonna get somewhere at ISC Bangalore.
Okay.
So he wanted to ask which one should I go for? Which it's not a black and white answer, but
Yeah,
what are
so
your take on it?
I'll be very honest. I have a lot of friends in my batch who had gone to ISC and IITs for their masters, and I believe the basic difference is in masters in Texas A&M or any other good school.
Hmm.
They expect you to have a very very good fundamental background. Okay, you won't be given the you won't have the time to kind of adapt to oh let me learn some control theory. Oh, let me learn some signals and systems. No, there is no time for that because they are delving straight into the circuits, and they have a assumption that this student comes with a very good fundamental understanding. Whereas in IT Madras and IST, I think people have
Hmm.
some time to learn the basics and
Yeah,
yeah, because right from day one, like we are given projects and assignments that are cadence based, and it's like designing like differential amps,
I
OTAs,
see. Hmm.
different compensations. So you don't really have the time to kind of settle in, right? So for me, it was like a top to bottom approach in case of learning, right? I learned all the big stuff first, and then I had to like go back again and learn the basics so that I could fully understand what I implemented.
Hmm.
But in India, it's like bottom to top approach, right? You first learn the fundamental, you first learn the
Right,
theory, you do assignments, handwritten assignments. Because I had a friend who is doing his master's from IIT Delhi, and I would see his assignments, and I was like, okay, fine. Like it's like they have a pre-lab where they're doing a lot of like mathematical analysis, small signal analysis, derivation, right?
right, right.
So here it's kind of different. Like we don't do much of that. Like we
Okay,
understand, okay, fine, like how to find the input compound range, how to intuitively look at the the gain of a circuit, bandwidth, what it matters. Yeah. So I think those are like really important the differentiator when it comes to pursuing.
okay, okay.
Yeah. So you have to
And
have like really good knowledge. Otherwise, if you don't have good support, I've seen a lot of students fumble and change their branch from analog to like digital or something else.
mm-hmm. Right. So, okay, that's one point. Another important consideration would also be the finances because those are pretty,
Yeah, I mean, honestly, Texas A&M is very cheap. I'm just speaking about Texas A&M in general. I think
okay,
because
okay.
I had admits from other good universities as well, from USC, from Virginia Tech, Penn State, but the fees here is cheap. And if you are like, because I came from like with zero background, right? Like
Mm.
so I believe like each student has a different initial condition, right? But we all achieve to like go to the same steady state, right?
Yeah.
So I feel that like yeah, you have to work hard, and here like I got research assistantship, so I think anyone can get, and there is an
Oh, okay,
option for
great.
being a grader. So if you are determined enough, if you are confident enough, I don't think like that's going to be a big drawback factor. The ROI
Uh,
from TAMU is amazing, especially when it comes to VLSI, analog or digital. So
and just to like quantify, how many students or what percentage of students are able to get those RA or TA ships?
it's it's not much, but if you have like, so you have to do well in the professor's class first to show
Right,
that
right.
you really know the subject. Secondly, here also professors are pretty biased about like who they pick. So like if you are from IITs, definitely they'll pick you first because they know it's a like a
Oh,
general
okay.
consensus everywhere, right? In IIT and BITS, they have like a different kind of like attraction for the professors because they believe that okay they will now start good research, they'll deliver like good papers because all they care about is citations, to be honest.
Mm-hmm. Yeah, yeah.
And but what happens right now, like I was having a very candid chat with my professor, Kamran Antasari, who teaches RF in our department. So he was saying that a lot of students are now running after a job, right? Because they're getting
Mm.
like really high paying jobs. So there's a very much like a gap in research right now. So they are trying
Right.
to admit like more students from diverse backgrounds so that they get more research profile, or also like if you have good students in the industry, right, automatically the name of the institution also becomes really
Right,
good. Like
right.
Texas Instruments is like a company that hires a lot from A&M. Then you have like Cirrus Logic, Silicon Labs, Skyworks. So like getting a job in A&M is very easy if you
So
are
I
good
was
in
going to
analog
come to
design.
that. So
Yeah.
because so people say that I don't know if it's true. I'm just saying that that's what I've heard that in US since you don't have a proper placement and especially right now with the economic turmoil, it's much
Yeah.
more difficult to get a job and you might go for a master's but then you will end up jobless. So
I think that's partly true, but that doesn't apply to our industry at all. Because
mm,
to be honest, semiconductor is a fairly stable industry, right? We don't see the boom of AI or ML, right?
yeah,
Because the boom of AI and ML, so they'll need more data servers. So that means like more products for us, right?
more
Like
yeah, yeah,
more
true.
power management chips, more optical communication chips, right? So I think that way our industry is good. Like when there is a demand, we are obviously there. But when like the market is down, I don't think it's a big factor. Yeah,
Yeah,
especially in
yeah.
analog. I've not seen much layoff in analog design because there's a dearth of analog designers, good analog
Right.
designers all over. Like especially I think in US you still have like a lot of universities, right, that do analog design, and a lot of people from like even from Europe, like from TU Delft, KU, when
Hmm.
they come to the US, right, because they're also like really good schools. And I think it's the same in India. I think with the booming industry, semiconductor, I think a lot more company will be coming uh, and establishing their like design centers in India because they already know like most of the design centers are like there's a lot of Indians and Asian
Yeah,
people.
yeah.
So
And also, I think the cost is cheaper for them in India, right? For the same job.
kind of, but I think that bridge will also be closing.
Oh,
Because
okay.
if you're doing the same work, if you're doing the same, because initially there was a notion that all the back end work is given to India, but now like there's
That's
proper
not true.
design. That is not true exactly, but
Yeah,
there's a notion, right?
yeah, yeah.
And like a lot of like verification work is passed on to India, and you have this and that. But right now that's not the state, right? So that's why I'm like,
Mm-hmm.
yeah, there's not much difference. Like, yeah, it's just that if you are interested in research, you should definitely do a master's because that also you'll understand that if you want to do a PhD or not later in your career.
Mm-hmm. Right, right, right. Got it. So, and yeah, how was your experience working with Professor Sam Palermo? So, just to
Yeah,
say,
I
I
mean,
had a
I
chat with.
actually, yeah, so I was his student in one of the semesters. I was doing like optical modeling for his some of his transceiver designs, optical modules. But I actually was initially like enrolled, and we had talked about like me doing a PhD under him. But
Oh,
I was
okay.
not really getting the feel because I think high speed communication and optical communication is something that is like not really like for me it's not really like analog, it's like very much like a digitally assisted analog, right? So for
Right,
me
right,
like
right.
I was kind of like struggling more because you need to have like a really good knowledge about digital communication because you're dealing with like different kind of
Mm-hmm.
modulation schemes and stuff like that. So
Correct.
and I think the most complicated analog circuit you will see there is like maybe a differential amp, right? Even the like for the gain stage they are using like push pull inverters, biased
Mm-hmm.
electric point. So it's not that challenging. I really enjoyed power management classes. I really enjoyed like the advanced kind of classes where I'm dealing with like multi-stage op amps, different kind of compensations, and so I think for that reason I kind of like yeah. But it was fun
Right.
working with him. He's an excellent professor. Anyone who is interested in serdes design, high-speed optical communication should definitely look up to his profile. And his courses are all available online from his
Right.
basic,
Yeah, yeah.
yeah. So those are, I think, used all over the industry. Like I got a call from Qualcomm from one of the directors just because I was Dr. Sam Palermo's student. So he wanted to know like what research I was doing because he was very interested in hiring me. But
Yeah.
sadly, I had to break it to him that I'm no longer. But it was a good
Yeah.
experience. I think I learned a lot. Yeah,
Okay.
he's
Yeah.
a very
So I
strict
had a.
professor, and the thing is that like he expects the students to know the shit really well. So he's always looking for people with like PLL background, with serdes background already, who can
Mhm.
come in and start the work right away. Like his, if you
Yeah,
look at
because
some
these
of
are
his
heavy topics.
students.
They take time to learn and all.
Yeah, and most of his like he runs his research group like a company, so he'll have like his top PhD students, like the managers, and then you'll have like
Yeah,
students
yeah.
from MS, working under him. And if you look at the profile of the students, like some are from Stanford MS and have like worked in Samsung for 3 years, then have come for PhD. Some have worked in like China for 12 years in the
Mm.
industry, and then have come for PhD. So obviously, their the level of their
Output would
background is
also be
very
different.
different,
Yeah.
and most of the students are like from top tier, like from like top tier Japan University or from like Seoul, from Korea, or Taiwan
Yeah,
National
yeah. I
University.
see.
So and they all have work experience. So for them, they already know what they want to do. So if you want
Mm-hmm.
to join a group like that, you should be willing to contribute from the first day. And how can you contribute from the first day if you already know the all the design aspects already, right? So it's
Yeah, you
very
have some
tough for
experience
someone,
already.
yeah, someone newcomer to just join his group because I was really intimidated. So yeah, if you want to join
Yeah.
Dr. Palermo's group, be sure you are ready with all the knowledge and the fundamentals before you go there.
Right. So that's actually an important point because in India, what happens is most of the PhD students in circuits typically they graduate beyond 5 years, like 6, 7 years. And the main problem is that because the first 2 years is just gone learning the basics and understanding
Yeah,
basic
so
courses.
that's what I was telling you. If, even for masters, it's true here. Like they are expecting you to come fully, knowing like BJTs, MOSFETs, op amps, signal and system, control
Hmm.
theory, like whatever is needed for analog design, right?
Right, right.
And there are many ways to analyze that. You're analyzing in time domain, so your control theory
Hmm.
matters. You're analyzing in like frequency domain. Again, there like you have signals and system and control theory. Different. So right now there is a trend of doing communication circuits, right? Like RF, millimeter
Yeah,
wave.
yeah.
So there you have to know good like analog communication, digital communication, like different modulation schemes, like
Right.
ISI, everything. Like nothing can go wrong, right? So
Yeah.
it's very difficult to like just go and try to grab like all those knowledge if you have no idea from before. So I'll just advise everyone to be prepared. Take your time, even if you have to like take a drop year or something. Read. I mean, there's Razavi's lecture in YouTube. Anyone can
Hmm.
like look up with basic
Yeah.
fundamental EC background and can learn analog design. So yeah, I mean, you have to be prepared with the basic theory for sure.
Right, right, right. Yeah. So, okay, we'll now switch to, so when people think of analog, especially in university, they think about the signal chain circuits like you mentioned, op amps, compensation, and all
Mhm.
those. But I saw that your profile, you work primarily on power side of
Yeah.
things. So,
So I think okay, this is very interesting. So whenever I saw TI's profile in India, right, I would see like okay, like who all are going there. It was mostly like PMIC parts that I would look at, right? Like in India, I think mostly there's so much focus on power. Like when I was doing some project on like microgrid tire inverters, like you would mostly see okay, like these are the chips from TI, and they were like mostly like power products.
mhm,
Sorry, so that's where I got like my interest in like and I think power PMIC is the only field where you have like rigorous analog because you have like a control feedback loop which is extremely
right,
complicated,
right. Mm,
right? And there is no digitally assisted analog there, right? And but
mm,
now with the like modern all the technology, you need like different trimming, you need precision circuits, so you have like mixed signal blocks as well. You need a temperature sensor, you have to have a ADC.
yeah.
So it encapsulates everything, right? And this, so the team I work with right now, we have digital control. So that's a different domain, right? Like
Hmm.
that's not
Yeah,
like analog control, like peak current mode or something like that. So that's a different domain where everything is like in mixed signal. So it's very interesting to me, and yeah, and I also like have interest in power IC design as well. Like I love like deriving like different mathematical models for buck converters or boost converters or whatever. Like yeah, so I think
yeah.
that's a very interesting profile to be in. It's very
Yeah.
traditional analog, but I do enjoy it. Yeah.
During my undergrad, when I just started learning analog, whenever I saw an inductor, I hated it. I used to think I didn't like the circuit at all when I saw an inductor. And in power, it's usually like all inductors, right? So,
Yeah, I mean, so yeah, I mean, so there's two aspects to it, right? As a circuit designer, right, you're also involved with the system level. If you don't understand the system level
mm,
intricacies, right, what's happening, right? How can you design a circuit, right? If someone asks you to design, like, let's say, overcurrent protection for a buck converter, you
mm,
have to know the inductor current property, right?
right, right,
How
right.
much peak it can go, what margin you should take, what is the inductor saturation. Not maybe in depth like an application engineer, but you
Mm,
have to know, and that gives you an upper hand basically.
mm,
So I think
yeah,
it's very important if anyone is deciding to pursue his career in PMIC, which is a very good field. You have to know power as well as analog. There is no
two ways
yeah,
about it.
exactly. And in a team, you'll have some people who are more experienced with power and devices, and you'll have some people who are more experienced with circuits. So that's the beautiful part. If you're like part of such a team, you can learn both as a young
Yeah,
designer. So you don't get yourself like constricted to a certain,
I see.
yeah.
Hmm. And since we are mentioning power so many times, what resources or references, if someone wants to, dive into this deeper, would you recommend for people?
Yeah, so I think for power, especially who are doing IC design, there is a fantastic course in Coursera by Dr. Robert Erickson. You
Okay.
have to go. So Dr. Robert Erickson's book is like the Bible of power electronics, and you
Hmm.
have to read his book. You have to understand some fundamental concepts like linearization and averaging that we use when we are modeling the small signal. Because power, you can't just say, okay, we can have a fixed DC operating point like an op amp and then just run some
Yeah.
stability and whatever, right? Uh, there are a very few fixed metrics when it comes to analog components. But for power, you need to know, okay, what am I averaging? What am I linearizing? Right? What all assumptions I have made?
Mm.
And mostly it's very hard to do on hand. So I think there are also a lot of TI app notes that help for, especially for beginning designers. For understanding like basic current mode control or like basic FET design. So I
Mm-hmm.
think TI application notes and those, I think there are like 5 courses, which is like introduction to power electronics, converter circuits, converter control circuits, and advanced
Okay.
control circuits. You should definitely read on those to understand like how actually the converter works and what all things are necessary inside. And
Yeah.
obviously there is a course in NPTEL by Dr. Kadir Khan
Mm-hmm.
from IIT
Yeah.
Madras. Excellent course. I mean, one of the best courses I've watched, and very intuitive. And the reference books that he mentioned, there's a Professor K. Hon Chon. His book on PMIC is excellent again. Like
Okay.
it goes into circuits as well as the system, so you understand both. Like it starts from band gap, LDOs, hysteretic mode converter,
Mm-hmm.
switching converter. So you'll have like all the tools you will need. And you have to look at application notes as well from TI. They are fantastic. So,
Got it.
and
Got
also
it.
ADI. ADI has like good tutorial videos online. Like they have the ADI wiki. So you
Right.
can
Yeah.
like go there and it's all there in the internet, man. Like you
Yeah.
can
You just have to look.
you just have to look, but just having practical knowledge, this theoretical knowledge isn't enough. You have to design circuit, you have to analyze. And when you are solving a problem, I think that's when, all these theoretical and practical insights come. Because when you are
Mm-hmm.
designing, you already know the specs, right? So you are kind of limited by that. You know what to
Right.
do. If anyone asks you to do like a two-stage op amp, you can like do it in like 5 minutes, like using square law,
Mm-hmm.
right? You just write a couple of equations. I think there's a book by Philip Allen, and he has
Yeah.
given
Yeah.
like step-by-step procedure. So what we used to do was for our first design, we used to script in MATLAB. We used to like extract all the technology node and just write the square law equations in MATLAB. Okay, I need this GBW, I need this much power. This is my common
Mm-hmm.
mode range. This is the BD stat. So I think these things are easy to do. The main thing is like understanding different type of circuits when given and
Mm-hmm.
doing that intuitively. And I think one of the main thing that kind of helps you to do that is very fundamental understanding of RC circuits and RLC circuits. I
Yeah.
think if you look at like even an inverter, you can just treat it like a RC circuit, right?
Yeah.
You
Yeah.
can
Yeah.
model it as a current source and a
Correct.
capacitor or RC circuit, non-linear RC circuit. So,
Right.
I mean, you have to like kind of then think about, okay, it's like charge transfer happening, right? So, as fundamental as you can go.
Yeah. I think that's why in interviews, at least at fresher roles, they usually test RC circuits and their variants.
No, it's not just for fresher roles. I think even when I was transitioning from fresher to senior, right?
Mm.
They expect you to have that knowledge even then, because obviously, like it's not something that you learn over time, right? It's something that you are bound to know.
Yeah. Yeah. It's it's like it's necessary but not sufficient.
Yeah,
Yeah.
yeah, yeah. It's not obviously it's not sufficient, but
Yeah.
if you can visualize circuits that way, right? Okay, I have like some delta V over here that's producing a delta I, and then it's going to an
Mm-hmm.
impedance, so it's a delta. So those kind of visualization don't come very easy, Especially students I've seen are, like there are some interns I've seen who are trying to like just learn it up. I'm like, don't learn it up. There's nothing to learn. Try to
Yeah.
visualize, like try to see, okay, this is happening. Like
Mm-hmm.
initially they don't even understand, okay, like, what is the common bias point, what is large signal, what is small signal. So slowly you have to understand. And I think one book which I'll recommend to everyone is Microelectronic by Behzad Dazavi. I
Mm-hmm.
have made a mistake of
Yeah.
studying Cedra Smith. I
Oh.
think that book got me a lot confused. And it's a good book. Don't get me wrong. I
Mm-hmm.
still have it. But I think the classic book would be Microelectronics by Behzad Razavi, Analog IC Design by Razavi. I think there is no book better than that. People might argue saying that, oh, there is like, other books in the market. Like during my time, there was like Professor Tony Chan Karuzan, whose
Okay.
book is very good. Then there is the classic Phillips, Gray Meyer, and everything. But I
Mm-hmm.
think Razavi's book, if you have to understand circuit intuitively and like quickly do
Yeah. Yeah.
the small signal analysis and stuff, which is very important, yeah, people
Right.
have to like kind of go through those.
That's right. So, and since you already brought the topic up, how do interviews evolve? So I'm pretty much interested in this question. How do
Okay.
interviews evolve from fresher roles into senior roles? Like, what's the difference?
So I'll tell you like a story of mine, right? So in my first career fair at TI, right? Uh, when I went there for my internship, they
Hmm.
ask you very basic questions, right? They ask you, okay, so they'll give you like a set of op-amp, like
Hmm.
inverting, non-inverting, summing, differential. Then it
Right,
moves on
right.
to like more challenging, like active filters, right? And they just want you to like do some kind of like if you understand like the basic of op amp or not, right? Derive
Hmm.
the transfer function. How are you doing it? Is there any approximation you are making? Then comes your diode circuits. Diode as rectifier or some like diode like series with resistor or whatever. Like they mix it up and stuff. And then comes your capacitor, charge sharing. That's a very important. Basically, there are a
Right,
lot
right,
of
right.
groups that work with switch capacitor circuits,
Yeah,
and
I was
that's
asked
what
these
my
same questions.
yeah, and that's somewhat my weak point was, especially like because I had to like see and then I would like always try to do like okay charge conservation. So I had no intuition because I knew okay I'll just try to do
Yeah,
charge
the same
conservation
happened with
theory
me
and
during my internship interview. So they
yeah.
asked this,
So
like, you transfer charge from one capacitor to
mhm,
another. And in my head, I was, writing those equations and seeing, like, you have to conserve the charge, you have to transfer
yeah.
it. So,
Yeah, and there are, I think there's a channel in YouTube called Analog Snippets, which
yeah,
has
yeah,
very
yeah.
good, yeah. So, like, I see most of those interview stuff from there. And in interviews also, as you go senior, right, people expect you to actually have those intuitions, right?
Hmm.
Like, if, like, there's capacitors with some initial voltage and they're connected together, the initial voltage doesn't matter. That's what, like, ultimately when you derive. So, all this knowledge, if you have, right, the interviewers will be more impressed that, okay, he has this knowledge. Or suppose there is like a normal output impedance circuit and suddenly someone connects a resistor, so the voltage is going to drop, right? So they expect you to understand why it is happening, where the current division is happening, they are becoming
Hmm.
in parallel, so all those stuff, you can't just sit and try to do math. They get very annoyed. They want you to first think to the circuit.
Hmm.
I've seen people, when they get a circuit, oh, I'll just take pen and paper and, write.
Hmm.
No,
Hmm.
think to the circuit what's happening, right? If there is a resistor in parallel, that means the current is getting split up. So try to derive using those, right? Instead of just trying to like, oh, let me like do I equal to B
Right.
like this and
Because it's like
that,
any
Ohm's
fresher
law.
who has graduated, he can do KCL, KVL, and solve those circuits.
Yeah, yeah. So they are looking for like more intuitive understanding and also like what all you have done, right? Like in the sense, okay, they'll ask you from an internship what you have done, what you have learned. They'll ask you from your current job profile. They
Okay.
will also ask you like, okay, fine, how much knowledge of even the simulator you have. Like they'll give you maybe like some kind of condition. They'll okay, how can you like if design this circuit and what all parameters would you expect to do. Suppose you're
Right,
doing
right.
a comparator. What are the important parameters that you look in a comparator, right? If there's a large signal event, is the op amp slewing first or it's going in small signal state? So
Hmm.
all those things are very important, and those
Yeah.
comes with even noise. I think noise is one of the things where people struggle the most
Hmm.
because they don't actually understand how noise, like it's current noise from each device. You have to understand that. It's not like so they try to like learn the equations. Okay, equal referred noise, I'll just divide by the gain and I'll write some
Hmm.
expression, and it's not like that. It's very easy to understand. Like even offset, current mirror and stuff like that.
Hmm.
What matters? It's the length that matters. So all these things, you have to like know it by heart, kind of.
Hmm. Got it.
So yeah, and it comes with experience. So they're going to
Yeah.
ask you more about your experience there. So the interview process does not change a lot, and it's pretty rigorous here. I'll tell you, it's pretty rigorous here. Like I had to give one presentation to the entire team. I had two
About
phone
your
calls.
previous work.
Sorry.
The presentation was about your previous work.
Yeah, presentation about your previous work. So that's the most tricky part because you have to select a circuit that you like the most and present it to them. And some expert will be sitting there and he's going to point out why have you done it this way and not the other way. So it's
Yeah.
very hard convincing them.
Yeah, yeah. Like in
And
design reviews, it's like
yeah,
they'll grill
exactly,
you.
exactly, exactly. It's just like a design review. You are presenting your designs, whatever you have done. It
Hmm.
has to be proper. You have to write down all the equations, what all considerations you have done, right? And then you're presenting it
I
to
see.
them. And they ask very deep, insightful questions
Hmm.
regarding what you have presented. And then
Okay.
comes a part. So if there are like six designers who are interviewing you, three will be probably asking you on like basic circuits, and three will be asking you about your education, like what have you actually learned in your job,
I see.
And
Got it.
some special circuit that you like, they'll ask you to draw it and do like full mathematical analysis. And you have to do like everything, like from input converter range to slew rate, whatever be it. If it's ADC, then the resolution of the
Yeah.
ADC, what speed, aliasing or anti-aliasing. Why have you chosen that ADC with that speed? So you also have to know about the application.
Right, right, right.
The yeah, so I think that's a bit difficult when you are going higher and higher because you have to justify what value you bring to the company, right? Because
Correct.
frankly speaking, if you work in a team, right, like later on, I think when you go higher up, you'll understand that analog design is not just about designing. Most of the talented analog designers are actually trying to debug the circuits, right? Because there are legacy products out there in the market that have been shipped already. Any issues, you can't just go and do like a all layer change. So it's
Correct.
like with the minimal, change, how can you actually make the circuit work? And that's where you're like most fun because you have the luxury of a few capacitors, spare capacitors, few resistors, few switches here and there. And make it work, you need to have excellent fundamental understanding. There, how much mathematical knowledge you have, how much you have done research in PhD doesn't matter. It's all about how intuitive you are and how quickly you can understand, okay, what can I do to kind of, suppress what the issue is.
Right,
So
right.
as you go
Okay.
higher up, those are some of the things that you have to deal with. Yeah.
And typically, how long do these interviews last and how many rounds?
So usually, like from what I've seen, so I've interviewed with a lot of companies. So usually
Yeah,
the
yeah.
standard pattern is you'll have a phone call with the hiring manager first,
Okay.
where he'll ask you about your resume. This strictly resume, what you have done, and he'll explain to you about your role, your future role in the company if you're joining in, right? So these are the blocks you'll be dealing with. This is who you'll be reporting to. We have this team member who is good in mixed signal, that this team member is really good in power. So he'll give you a brief overview and he'll ask
Okay.
you a lot of questions about your resume. Like, oh, if you did a LDO, like, what was the pass size transistor? Okay, if you did a band gap, like what was the sizing of your PNPs or LPs, whatever you have used, and why like that? Need to consider the two feedback loops? How did you mitigate the stability? Whatever, like generic questions he'll ask you. Then some companies have straight like 6 to 8 hours of interviews. Like you'll be
Oh, okay.
interviewed by 8 designers over 2 days or 6 designers in one day. Renesas for that had an extra step. I had to give a presentation to the entire team. So yeah, but
Got it.
usually, yeah, it's a or
Pretty
some
extensive.
team have two screenings, two phone screenings,
Okay, okay.
and
Got it.
it will be like if it's in person, the whiteboard, they'll make you like do everything on the whiteboard. There is no like it's not like you won't
There's
have
no
the time to
mercy.
just sit and speak from moment the clock starts. Or some will have their own, people like some kind of like TI weirdly has its own some PPT file they'll open up and they'll have like 20 slides and if you can finish the slides within that
Yeah,
hour, that's
I
how
think in
TI
my
is.
interview, so my interview was virtual because of COVID that
Mhm.
time. But I think something like that happened because my manager, he had some presentation with him and then he was just going through and asking questions.
Yeah, so TI, I think here like TI's interview is kind of like it depends on team to team, right?
Yeah, yeah, yeah,
So one
definitely.
team I interviewed with was like, so I got a reject from that team because I was not senior enough for the role. So they referred me to the sister team where the guy just came. He asked me this like 20 stack question. There was another guy who was there in the interview and he said, oh, your analysis is very good. And those are like, trust me, the most basic questions you can get, right?
Mm-hmm.
Like the most basic questions you can get. You just have to like apply a bit of brain that, okay. And
Yeah.
those you have to solve. It's not like it's a textbook question, right?
Hmm.
They have some
Yeah.
trick circuits, they have done something, but if you know the analysis part is very easy, like, okay, fine. So I think that's what matters. Anywhere you go, they will ask you fundamentals for sure. At some point, they'll ask you the fundamentals. Be it
Got
RC,
it.
be it RLC, be it op-amp, be it signals and systems. Because most of the companies who, like for those people who are interested in ADC design, make sure you have very good fundamental background on DSP.
Right, right, right.
It's all about signal processing in mixed
In
signal
ADCs,
design.
yeah.
And you have more credibility if you know how to do like DSP algorithms for correction, for this digital
Okay.
correction in the background for like your ADCs, for your op amps, whatever be it. So
Got
DSP
it.
is a must know if you are doing ADC air, they'll have a separate interview round of just DSP.
Okay. Got it.
So
Got it.
yeah.
Yeah. So, and since you worked at multiple companies, so
Yeah.
which one do you think had the best work culture, or which one did you enjoy working at the most?
So I think during internship, what happens is you are trying to learn and also you're trying to impress your mentor. There are two
Right.
parts
Right.
of it. So my first intern was in a startup called Insiga, where it was
Okay.
like it was headed by the director of Mecom, Vikas, and it was a very small group. So I got to learn a lot. It wasn't very pleasant because we had to work a lot. We were doing manual layouts, right? Designers were doing
Hmm.
layouts. We were like even we didn't have standard cell libraries, so like D flip flops, inverters, whatever we
Right.
needed,
Right.
switch we were designing by hand. But that gives you good on-hand feels, right? It's circuit design at the end of the day. We would often
Hmm.
cry like, "Oh, these are like digital circuits, man. We get it like in standard libraries.
Hmm.
Why do we need to design that?" But I think it's good to understand, like even when you're designing digital circuits, you understand a lot about like trip points and what.
Yeah. Yeah.
Yeah, and
Yeah.
in TI, I had a wonderful mentor, so I learned a lot there. And I mostly learned about power there, not much about circuits, because we are
Hmm.
working in like the power domain. So I felt that team was more like more in power than circuits.
Yeah.
And with Dr. Dave Peralt, I think in his group, the startup was ETA Wireless. We were acquired by Munata. And it was like I was given full ownership of designing my peripheral circuits. So just out of school, just 1 year experience in ADI, which was okay because ADI was a big company back then. I was working in the automotive group, and I was to get like really like very less work because there's this belief that okay, for, like you can't give like important circuits to a newcomer because they might mess it up or they might not do
Hmm.
the full coverage of the circuit, right? So I mean, I got decent amount of work, but in the startup, like because we needed someone to step up and take ownership of the blocks. So I got to work with some of like wonderful people. Like there's a guy called Kapil Kesarwani who actually is working TI right now. He
Okay.
is from IIT Madras and graduated from Dartmouth, and he was doing his postdoc and stuff in MIT, and he was like my lead PMIC
Okay.
designer.
Okay.
So I got to learn a lot from him, and that was one of my best time. I like got to like design circuits and see them come back in shape, and when your all
At
peripheral
ETA
circuits
Wireless,
work,
right?
yeah, like band gap, LDO, like thermal shutdown, all the comparators, GM blocks, everything. Like it
Hmm.
feels really great. But it was like basic textbook design because we were trying to design some prototype, right? It was not some advanced circuits with a lot of like auxiliary stuff that we usually do. Like
Hmm.
proper ESD,
Yeah.
proper digital state machine and stuff. We didn't have that, but it was good enough, robust design just for the prototype that we needed. So after we got acquired, I interviewed with a lot of companies. I had the chance to work with Skyworks, TI, Renesas, and I found that the team in Renesas was really good. And right now I'm working in that group. It's a different field. We design your power management chips for server applications. So it's like
Okay.
100 of amps. Even though your
Hmm.
output voltage is like zero point 0.9 or 1 volt, whatever the CPU needs. And it's a step down from like 48 volt to 12 volt and then down to zero point 0.9. So it's a big step down. Your duty
Hmm.
cycle is like really low. So you have to face like the issue with like narrow pulsing and stuff like that. Hundreds of amps, right? So there's a lot
Even the
of
ground bounce would matter in that
yeah,
case.
oh my God, the ground. So that's the main thing. The ground bounce is the main like substrate injection.
Hmm.
So there I feel, oh man, like am I designing circuits or am I like doing device physics or? But it's fun. It's
It's
challenging,
interesting. Yeah.
and I feel that like a team should have a very good, well balanced. Like we have teammates like who are very good in analog design and simulator. Like right now, I'm
Hmm.
learning motion scripting for post processing of my data, and it's much more powerful than Maestro or assembler anything. And initially I would just blankly, I've seen most of like even my peers, they don't know what the simulator is actually doing. They'll
Hmm.
press on tran, they'll press on DC, they'll press on STB, loop finder,
Yeah.
whatever.
Yeah.
They're
Yeah.
like, oh man, cadence is giving me this and that. But they don't actually know what kind of script is running behind. I think most of the engineers haven't even opened like the options inside the tran, like where you can actually see like what's different
Obviously. Yeah.
options you can see. So I think designers are like, okay, I'll design the circuit, let the simulator do its work. But here, when I've come, I've actually understood what's actually going behind. And all you can do that is by reading the fucking manual. The cadence manual is there. You can read and you'll be amazed by what you can do in ocean scripting. So I'm learning all those things. So those are
Yeah,
something
yeah.
new to me. And some people
Okay,
might say, oh,
cool.
that's not what a designer does, right? But I strongly condemn those. Like it's like you have to learn about your
Yeah,
tools, you have to learn about the circuit design, you have to learn about the system, everything. So
yeah,
right now I
yeah.
think I'm at a really good place and surrounded by like all smart people. My supervisor is from Stanford, so like
I
I get
see.
to learn
Yeah.
a lot from him, and it's obviously good. Like if you have like good names and big names, right? Because of the alumni connection, you get to meet a lot of smart people. I even
Yeah.
have like working like with me is there's a guy called Mark Alexander. He was intern with Bezad Razavi in National Semi.
Mm-hmm.
So he knows
Okay.
Razavi, they interned together. And so, you get to hear a lot of stories during that
Yeah,
time,
yeah.
like how they used to do the circuit design back then with like no, like, analog artist kind of like
Mm-hmm.
what we call now ADE and stuff like that, right?
Yeah, yeah.
So I think, like, yeah, changing companies, I think you meet with different people and you get their perspective. And as a
Mm-hmm.
young designer, I think you should be humble and try to absorb everything.
Okay, okay.
And if you don't understand anything, go back, read your fundamental books. I think that will help. Otherwise, you'll be
Mm.
stagnant. You'll be known as a block specialist. Okay, give this guy a block. Let's do it.
Yeah,
And I
yeah,
think
yeah.
that
Got it.
anybody can do. Like a new fresher can also do with some guidance, and a 15-year-old guy can also do. Just that their
Mm-hmm.
understanding of the circuit will be
I
different,
see.
how they perceive. Yeah.
Right, 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 right. Yeah. And so one more thing. So you worked at startups and also at big companies.
Yeah.
So like people usually say that in startups the learning is much more, but in big companies uh it's more structured, so to
Yeah, it's,
speak.
I completely believe in that. That's a generic statement, but it also depends a lot on your team, right? Even so, in
Yeah.
TI, right, I interviewed with a lot of teams because TI has this like they randomly place people in some team. I don't know how they do that, right?
In the
Like
start, yeah.
I wanted to because I was working with Dr. Sam Palermo at that time. I wanted to get into the high speed team, and they placed me in the power team. And
Power.
later, someone who was working in power was working in the high speed team. Like they make all this kind of because the HR is
Hmm.
mainly responsible for placing, so I don't think they do a good job there. But I feel that startup you'll obviously learn more because of the pressure, right?
Okay,
And
okay.
it's not that okay today I'm designing a circuit, let me take a break and learn more about it. No,
So
then and there you have to learn about the circuit, design it, implement it. And I learned the most in my startup to be honest. Here I'm
okay.
learning more technical niche stuff that will be applicable only to the product line, right? Not everyone is designing SPS. There are very few companies that do that. Renesas, Infineon, and
Yeah, if I may interrupt
MPS.
you. So like as a let's say fresher or a young engineer, like 1 year experience or so, what do you think? Since you mentioned in startups you would learn much more. So in the start, do you think someone should join a startup? He might be better off
No,
there.
no, 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 no. So,
Okay.
where you join, basically, even if you join a big company, right, if your team is good, you'll get to
Hmm.
learn a lot more intricate stuff. That's the
Right.
thing. It depends on your team. Still, big companies have at some point been a startup, right? Like, they grew.
Yeah, yeah, yeah.
And the thing is that you will have so much resources. Like, startup don't have resources, man. Like, you will
That's the
be
main.
designing with the bare minimum. What you will learn is like you'll get more proficient in, being like more street smart about the way you do simulation, about the way you manage your licenses. Maybe you
Hmm.
are the one who is installing the PDKs. So you become a
Right.
jack of all. But if you have to be a master, if you work in a good company, because of the resources and the amount of people available, right? Like you'll have
Correct,
like
correct.
some people who are expert in LDO. Someone from Shanti's group comes, he's an expert in ADC, Delta Sigma.
Hmm.
Someone from Krishna's, student come, he'll be a like general analog and high-speed communication expert. Someone from Saurabh Saxena's group come, he'll be an expert in PLN. So
Yeah.
they'll be mostly in TI or big companies, right? Because obviously, that the pay also matters. So you will be in interaction with them, and then you'll have a much better advancement.
Hmm.
But in
Correct. Got it.
startup, like I said, the learning is like very much dependent on like what position you are put in. Obviously, like there's pros and cons in both. And I think
Yeah,
one
yeah.
should experience one. If he knows that the startup is doing good, they have very
Hmm.
good people. Like I chose my startup, my first startup, like it was headed by the director of Macom, and one of like senior scientist in Broadcom. So I know I would learn a lot from these people because they have been in that position, right?
Right,
The
right,
second
right.
startup was headed by Dr. Dave Pearl from MIT. Like nothing
MIT,
can go
yeah.
wrong there. You are meeting with some of the brightest minds, right? Then again, when you're interviewing, you have to make sure that you have to also understand like how your team is, right? If you, it's not just I got a offer from Qualcomm. If my team gives me like
Yeah, yeah,
shit
yeah.
tasks to do,
Correct.
I will not grow. So it ultimately depends on the team. So one thing I always encourage the students to ask is ask about your day-to-day task in the interview
Okay.
itself. Don't be shy. What
Hmm.
blocks you will be handling on, what blocks they are currently designing. Look at the data sheet. Look at that and you'll understand, okay, am I actually interested in doing this or not? So
Mm-hmm.
after
Right.
1 year, you'll have some understanding of all this. And you also
Got it.
have to be very frank with the manager that, my goals and aspirations are to do this, this, and this. Please tell me if that is aligned with the
Hmm.
team's need or not. So I think you have to
I
like
see.
clarify that from the front. Yeah.
Okay. And so another question was that you typically it's a rumor or myth that I don't know if it's a myth, but people say that whenever you switch companies, you get like a 30% hike at the bare minimum. Is that true?
Not 30% high. I mean, you can get it's dependent on your negotiation skill and how well your interview has gone, to be
Right,
honest.
right.
Right? If you are an average candidate, say they'll be looking for more candidates, right? And
Mm-hmm.
at the same time, if they did not get the candidate, they'll come back with the offer and they'll be like, dude, this is what we have to offer you. Take it or leave it. Because
Hmm.
they know what your potential is. They are experienced engineers, the one who are like interviewing you, right?
Interviewing,
You can't fool
interviewing
them.
you. Yeah.
There is no way you can fool. There is no way a junior analog designer can fool the senior analog designer. Even if, I feel even he's from the top IIT, even if he's like Razavi
Mm-hmm.
student or whatever, it doesn't matter. You will be caught like how much value you bring to the team. So you have to have a very good interview, and it also depends on the market, right? If there's a shortage of analog designers, obviously,
Right.
like you'll be. But
Yeah,
yeah,
demand
it's
supply.
a
Yeah.
general thing. If you're bringing some value from one company to the other, especially this culture is in Silicon Valley, right? So if you see most of the
Hmm. Yeah.
companies will have similar design. Today you go from TI to ATI, you will find most of the designs are pretty similar, except some.
Mm-hmm.
Some there will be some specialization, but that's how the industry actually evolves, right? Knowledge sharing. So one
Hmm.
guy has some good knowledge about some company, maybe not secrets, let's just say
Yeah, yeah,
some
yeah, yeah.
good IPs, and then he goes to the other team, and what he's bringing is that knowledge with him, right?
Hmm.
And so
Yeah.
if that knowledge is worth a lot to the team, obviously will be paid well. And at the end of the day, it all only depends on how well you have cracked the interview, how well the team thinks you are.
Correct.
Because here, like it doesn't matter how well you are dressed, how well you can speak English, right? It just
Hmm.
depends on your technical ability. That's all. That's all they care about. I have given interview in my Skyworks in like chappal, in slippers. I
Oh,
still remember, I had an advanced analog class. I did not sleep the entire night. I went to sleep at 8 a.m. in the morning. 11 a.m. was the interview for internship. And I was just wearing like, trousers and normal shirt. And I was in sleepers. And the people in front of me were all in like suited up and stuff. I still got the internship
okay,
call.
okay.
They don't care. It's just on your technical ability.
Hmm. Got it. Okay. So that's okay, that's good. And then for someone, let's say who did his graduation from India, he's working in India right now, he has some
Mhm.
experience, let's say 2, 3 years, and
Yeah.
then he wants a job in US, but he didn't go for a master's there, maybe let's say for financial reasons. So how does he get a job over? Is it possible? Have you seen people?
I have mostly seen people with more experience actually. I'm not gonna
Okay.
lie. I have seen
Yeah.
people like from top IITs and ISCs, those who have done their masters. Maybe they don't belong from like top tier university from bachelor's. Doesn't matter. Once you have
Yeah.
done the masters and reached to that level, it's all
Yeah.
good. But it requires a lot of effort. So I believe if you want a job abroad, if you have two,
Hmm.
3 years of experience and you really know what you are doing, you should definitely go for a master's or PhD. I believe.
Okay.
Because,
Okay.
yeah, at that time, you can ask the professor
Even
for
even if someone
research
already has
efficiency
done a
and stuff.
master's.
Sorry?
Even if someone has already done a master's in India, you should
I
again
mean,
go
it's
for
a
it.
very controversial thing, but I've seen
Yeah.
a lot of students from China, tops like C9 universities, right? I'm talking about
Hmm.
Peking, Fudan. and colleges
Wow.
like that, which are like the top tier. I've seen
Yeah, yeah,
people
yeah.
from Taiwan National University. I've seen people from Seoul University. From they
Okay,
have
the
all
top
have
university.
masters. They all have masters, and they have come again for their masters. Maybe it's easier way to do that,
Yeah,
but
yeah.
I think it's tough. I don't know, like, or you have to be on a lookout in LinkedIn, you know. But
Hmm.
usually people prefer to hire locally. That's the big thing, right?
Right.
The
Okay.
visas and all are involved,
Yeah,
right?
it's
At the end
easier.
of the day, it's the paperwork that hinders you, not the talent. You have to understand that. It's not that they're biased against people in India. No, they're not. It's just that they have to do a lot of more paperwork, and they can
Correct, correct.
easily get that candidate in USA itself. Man, there are so many good
Right,
colleges,
right,
right?
right.
Who have like practical experience working there itself, right?
Hmm, hmm, hmm.
So I believe, I think the best, like I've seen the guys who have done the best in analog have worked in India for a couple of years. Then they've either come for masters or PhD. Like even I've seen Shanti Pawan student, right? They have done their BTech in IT, they've done their
Yeah.
masters in IT, they've worked in TI, then they've come here for like another masters, and now they're working like big companies like Apple, whatever, you
Hmm.
know.
Right.
So I think that's a good move. See, if you already have the knowledge of analog, right, you can easily ask for assistantship.
Hmm. Correct, correct.
So I feel that you have a much higher chance of getting a RA ship or a TA ship. Much higher. Because you already have a profile. It's
Yeah.
much easier to get an internship. If you are from TI, from India, if you come here, TI will automatically take you for intern. So you don't have to worry about anything. You'll automatically get a job. I've seen
Hmm.
people come from Qualcomm, from digital profiles like say ARM, NVIDIA. They have worked in NVIDIA for 3-4 years in India or Samsung Research. They come
Right,
here,
right.
just do like the bare minimum course because they're already familiar with it, and then they easily get a job. You will earn the money back in internship itself.
Oh, okay, okay.
And if you're interested in PhD, that's a different issue. Like,
Hmm.
I
Yeah, it's a
feel,
different ball game.
yeah.
Yeah, I personally was in the start interested in a PhD, and then during my master's part, so I actually at IIT you join as a bachelor's, like at
Mm-hmm.
IIT Kanpur specifically, and then you convert to a master's if you're interested.
Okay.
So I was interested in a PhD. I thought I'll just convert to a master's to get a more deeper
Mm-hmm.
flavor of research, and then I'll go for a PhD. But then during my master's, my plans changed, so I didn't end up
Okay.
going for a
I
PhD.
mean, I've like worked with when I was interning in TI, there was this guy called Nilanjan Paul. He was DR3 from IIT Kharagpur. Even
Okay.
he had the same profile. He had done his dual degree from IIT Kharagpur
Hmm.
under Amit Patro, Professor Amit Patro. And I think now he had done now his PhD, finished his PhD in UIUC under
Hmm.
Dr. Pawan Hanamolu. I think
Yeah,
PhD
yeah,
is
yeah.
also a very good option if you're really interested, in doing research. Because people often have this notion that, oh, like if I do PhD, will I get the job? The ROI, is
Hmm.
the ROI good enough?
ROI,
No,
yeah,
the
right.
ROI is not good enough if you're thinking in terms of money
Hmm. Hmm.
or career, academic, like industrial career. It's much better if you have like a master's degree because you will learn a lot on the job and on the job, right? Like you will realize later, like in your later phase, it's not only about design. There's a lot of things involved, right? Like you have to
Yeah.
understand packaging, you have to understand board design, you have to understand like what the customer needs. Like the most abstract thing is deriving specifications for a block or your
Hmm.
product,
Yeah, yeah.
right?
That's what
As a
I was
system
thinking.
guy. So you have to understand the market. So all these things goes into it, and PhD doesn't teach you that. PhD teaches you to be extremely efficient and expert at the
Specialized.
circuit or the research area of your interest, right?
Right, right, right.
I have seen guys like do their thesis and everything in like say sensors or like wireless PA with this power transfer, this
Hmm.
energy harvesting, and then they come down and are still designing like basic two-stage amplifiers. Is this justice? I don't think so, but yeah, it is
Yeah,
what it
yeah.
is. Only if you have like very niche interest, only then go for PhD. That's what I feel. Obviously, they are much. I think they are much better at understanding and evaluating circuits than us. But with experience, you can get there quicker. I feel because you are
Okay.
already surrounded. You'll have someone in your team who is a PhD. You'll have someone in your team who is
Hmm.
extremely good designer, and it's your duty to kind of understand like how he is analyzing the circuit so that you can try to do the same.
Yeah, you can absorb all the good parts
Yeah,
from them.
yeah. I feel that's how I have learned, and that's how I have like progressed in my career. Initially I was very intimidated in it because obviously, with zero background, you go to such a good university,
Hmm.
and then you
Yeah, I
hear
can
that it's
understand.
so tough. This like it's not easy to even now. Like it's not easy to get a design job in USA. Like most of the people, my friends, ended up in design verification. Like TI is doing AMS verification, right? So
Hmm.
most of my friends have been like doing AMS verification. There's actually a friend of mine called, I don't know if you know him, Akhil Burgess Matthew. He is also a graduate from TAMU. He recently joined TI Bangalore as a AMS verification. He was working in Cupertino before. So yeah, a lot of the students, even though they have very good knowledge, it's not that easy to get design job.
Okay.
So yeah, you
So
have to
for
like
someone who might be
really.
watching, he might be intimidated just by hearing that
No,
because
no, no. It's nothing like that. See, like I said, come from a tier two university, right? I don't come from some fancy IIT or something. And like I'm saying, it's just a bit of hard work. And
Mhm.
like you have to know what you want to do. And like the learning will be from, again, top to bottom instead of bottom to top. I believe that bottom to top learning is the best because you're already building a fundamental, right?
Yeah, yeah.
And you
It's like
can
brick by brick,
then.
you're just setting it up.
Exactly. But when you're building a top to bottom approach, right? Like sometimes you might know a lot of things, but you don't actually understand what's actually going on, right? You just know, okay,
Hmm.
this statement is correct. But what's the,
Yeah, yeah.
yeah, working behind those
True.
statements, yeah. So I believe with experience, with perseverance, yeah. But like I said, it's not that easy. Like I don't want to fool students into saying, oh, just come and join analog dealers. I know you have to do a lot of hard work.
Hmm.
And if you don't want to do that, then probably do digital or software. That's my
Okay,
advice.
okay.
Because I've seen a lot of students like they have changed their stream after first semester, and
Yeah,
they're also from like ITs and NITs. So
yeah, yeah.
that time your college tag doesn't matter. What matters is
Yeah,
like
nothing
how
else.
much time you're invested. Even as a designer, Tejas, even you know, right? Like you have to study every day. Some
Yeah,
problem comes up, you have to like look at different things, look at research papers,
you
what
have to
new
keep
things are
upskilling.
going
You
on.
can't, just be stagnant.
Yeah, someday your manager will come and say, "Oh, I need like a very low IQ temperature sensor. Get me one."
Yeah,
At
yeah,
that
yeah, yeah.
time, as a senior designer, right, you can't be like looking for help. Oh, what are the specs? Where do I look at? You have to like read papers. You have to
Right.
understand. And then if you design something which is over designed, your manager will go, "Oh, it's over designed. You don't need so much complexity." So that's another thing. You need to understand like what all is required.
Mm.
So that intuition and all those will come slowly, like and that will differ from person to person. And I believe like it's like RC. The first 50% is 0.69 RC, and full settling is like 7 tau. So
Mm-hmm.
there's a huge difference, right? It's very slow once you like reach to a certain level amount
Right,
of
right,
learning.
right, right. Got it.
Yeah, so
Yeah. So now, how does a typical work day for you look like? How much hours? I know there's
man,
no
like I
limit like
think
that.
it's like my work-life balance is really good here. I mean,
Okay.
except the startup. I mean, even in startup, right? I would say like the work-life. If you're very like I was very satisfied with what I was doing. I was like designing circuits. I was my own owner. Like okay, I own these circuits. Like
Yeah.
these are coming back. So that gives you a different feeling. But then you don't have much work-life balance. You're working for like more hours and stuff like that. But if you're in a big established companies, the work-life balance is much chiller.
Yeah.
Only during tape out time it's
Mm-hmm.
gonna be hell. Or if there is a part out in the field which has some problem, man, you have to recreate that issue. The thing is that you have to recreate that issue, you have to solve that issue, and you have to convince the management that
That's
whatever
the
you're
issue.
proposing is correct. And
Yeah.
and they don't understand the technical stuff, so you have to like make presentation where you have to dumb down the thing like
Mm-hmm.
simply. And then there is like the technical part, right? Where like the director and everyone is sitting with like 20, 30 years of experience, and you are discussing all the high level technical stuff with them. So that time it becomes really hectic because you really have to do your homework there. You
Right,
have to
right, right, right.
understand the circuit that has been designed for what purpose, because you might improve it and break something else, right?
Mm. Yeah.
So all those things have to be there, like reasoned there. So I think during those tape out, and if there is any bug in the circuit, that's the time where you just need like more work time and attention. But apart from that, I think the work life balance is pretty good. Like there's like no fixed time that you have to go to the
Mm-hmm.
office. It's just you have to do your work, hybrid culture as well. But I prefer going to the office because most of my
Same, same.
colleagues come and I learn a lot from them. Like just casually chatting, like there's a whiteboard, draw up some
Yeah.
circuit. It's fun. Yeah. So I think it's very
Okay.
good. Like the work-life balance here is pretty chill. I haven't worked in India, so I don't know. There's no
Mm-hmm. No,
like
it's
base reference for comparison,
like
but
I don't know about my friends, but like for me at TI, it's pretty good. I mean, it's the perfect
yeah, I
balance,
think
I
it
guess.
also depends on your team, man. Like it also
Yeah, it
depends
depends
on
on the
like
team
how your
exactly.
manager and your team is. It depends a lot on that, and also a lot of it also. So sometimes people think that, oh, I have a very good work-life balance. Does that mean you're getting enough work? Does that mean your team trusts you or not? So sometimes I have a feeling of that.
Oh.
So it's very important to do one-on-one with the manager. I feel
Yeah.
that like because what happens is when you join a new company, right? You have to prove yourself, right? So they'll start
Yeah,
with
yeah.
small tasks, and you are like, oh, these are small tasks. I don't want to do it that way. So they'll understand that, oh, like then they'll like get afraid to give you the big circuits basically or the big responsibilities because they see
Got
that
it.
okay, small tasks that have been given to you has not been done properly. So it's very
Hmm.
important. Whatever task you get, maybe it's parasitic extraction, maybe it's running
Hmm.
like post layout simulation. Do it properly, and if you have like done something like I was doing EMIR, right? And as a senior engineer, I'm like, why? Like it's a CAD flow basically that you have to run. But in our team, we do like we check everything. Like we are checking like how the current is flowing into the circuit. We're actually manually looking at the like layout and trying to correlate the whatever the tool is saying. So we're not completely relying on the tool. And I found so many bugs that I had reported back to the CAD guys and cadence that the voltage tool is doing this. It's wrong. That's not how it should happen. So the team knows that okay, you're not just running simulation. You're not just a
Yeah,
spice
yeah.
monkey. You're actually looking
Yeah,
at the
yeah.
circuit and you're trying to understand like what is going on. So I think it's very important to give that impression as well, because most of the people like are spice monkeying around. I feel so it's
Yeah,
very
yeah. That's
important.
true.
And I've been fortunate enough to work with people who have actually made me realize that.
Hmm.
Because once you're out of college, you're like, oh man, like Cadence will take care of everything. Like I can run everything in Maestro. It's a very
Yeah.
cool software. Like do all the Monte Carlos and corners and finish. No, you need to know like what's going on and yeah, how things are. So
Okay.
I think that's
Got
a
it.
very important aspect of being in a analog industry because you have to evolve and adapt as well with time.
True, true, true. And regarding the documentation, I read on your LinkedIn someone gave you a recommendation and he specifically mentioned that your documentation was like phenomenal. So, do you
So I
like?
think no, like first of all, when I see a circuit, right, I'll immediately search for my textbook. That where have I seen a similar circuit, right? And I'll try to understand the large signal as well as the small signal aspect of it, and I'll write it down in a piece
Okay,
of paper or my notebook document. Then
like
I'll
the
go and tweak
summary
the
or like
circuit.
the basic summary
Yeah,
of
yeah, a
that.
basic. Then I'll go and tweak the circuit. Then I'll try to understand, okay, why has he placed like a capacitor here? Why has he done like maybe an indirect compensation here? What's the advantage? Like, okay, then like do kind of like small signal, large signal, and I have a very good this way of like documenting all the test benches, all the runs. I think some people just like they show the test bench, some simulation results, and some remarks, like 3, 4 slides. I mean, that's not enough, man. Like,
Mm-hmm.
if you are characterizing, say, even the basic of op amp, right? It should have all the parameters. How much current is it drawing? What's the GBW, DC gain? What's the settling time? You also have to look at the large signal. You have to look at the small signal. You have to look at the supply current. If there's a floating node in the circuit, you also have to check that. So it has to be proper. And I always write a proper like documentation in the sense that okay, this is a constant GM bias how it works. So I kind of like look at the note, like look at the book again, try to again like
Okay.
revise, and then so that really helps me when I look back at the circuit documentation. I know everything I need to know.
So,
So
do
I think
you
that
do
I've
these
learned in
things
the
like
startup.
towards the end after everything is done, or while designing itself, you
No,
make
no,
some
while
notes?
designing itself, while in the design. So the thing is that once you run through the entire suite of simulation, right, you're like, man, I have to run and like go back and do all the simulation again for documentation. That becomes like a tedious work, right?
Yeah, yeah,
And it's
yeah.
it's it's, it's time not well spent for a designer,
But
to be honest.
also, so when you're designing, it's like a iterative process, right? You the first time you
Yeah.
design, you might not even use that again.
Yeah, so
So,
what I do is I so what my suppose I'm designing like a on chip or off let's say off chip LDO, right? And you know that the dominant pole is at the output, right? And if I do a Miller cap from the OTA to the pass transistor, it's a bad design, right? But maybe I don't know initially when I started designing that maybe I didn't know that or maybe I did not think about that. Then I realized, oh man, I'm making the system more unstable, right? I'm introducing to low frequency pole. So I'll write that down. Sometimes I'll write, okay, this current mirror sizing
oh,
was not done correct, or the current density was. So I'll write everything down, whatever So I kind of like talk to myself, like why it
I
has been
see.
done, and I write all my thoughts down, and later I refine it. I don't show everything to everyone, obviously.
Mm-hmm.
And like even my like all the design reviews, most of them like I have like circuits drawn by hand, not Visio,
Oh, so
and
you
that's
like
just
take
in
a
the
snapshot
appendix.
of it and you put it in the
Yeah,
PPT.
and that's just showing like all the signals. That's like, see, if I'm presenting in front of like a team, right? I have to obviously do the diligent work, but I also have an appendix where I show what my thought process was at that time. Why did
Oh,
it
I
change?
see.
So I can like later go back and retrieve that. So I feel
Mm-hmm.
that documentation really helps me as well as puts a good impression to the team that this is a
Right,
guy
right.
who is diligent with his work.
Hmm.
Be it a very simple simulation that might not be required, but still. And if you see, some
Yeah.
people have seen like, they, if they see some weird behavior in the simulation, right? They'll be like, oh, no, no, the DC gain and the crossover is okay. It's okay, man. If there's some peaking, doesn't matter.
Yeah,
Man, you
yeah,
have to
yeah.
understand what's happening. Like,
Hmm.
are you introducing some conjugate zeros there that there's a peaking, like doublet? People don't really care about that. So that's something that I've learned in this company to look and analyze at everything and kind of try to understand why that has been designed at the first place before you go and like, oh, this designer did not know anything. No, he knew everything. There was a specific application for which he designed that.
Hmm.
Maybe that application is not correct for this circuit, so you have to get around that. So yeah, documentation is definitely very important, and I always write it down. Right, if I
Yeah, so
see
you
any
like
new
use a
circuit,
notepad or a notebook and you like
I
jot
have
everything.
like, so I made this like mistake of writing everything in my notebook. So I have like around 15 to 20 notebooks. So I have like notebook for like TI internship. I have a notebook from like my time at ETA Wireless. So I still have like 4 notebooks now already. So like whatever I learn, I quickly write it down.
Hmm. Okay,
So
okay.
that's I think very helpful. So suppose like some test bench I saw and I was like very curious. I'll ask the designer who made that test bench and I'll write down, okay, like he has done this. So he's emulating. So especially in power switches, right? You have to model the parasitics. Like
Hmm.
you say, ground mounts. Why? It's very easy, right? It's like V equal to LDI dt. And then I
Hmm.
comes from because you're charging a huge cap, right? The FET.
Yeah.
So I equal to C dV dt. These are the two equations that you just need to write. And
Hmm.
based on that, you'll get like all the like, the ground mounts and everything. So you need to model the parasitics in the test bed. If you just put an idle voltage source, it's AC ground.
Yeah,
It will
yeah.
absorb all your transit. So all these things are necessary. Initially, I just used to do like, the basic minimum test bench. But then I slowly started evolving more complex test benches. And that's what shows like the difference between like someone who has just joined and someone who has
Hmm.
been working for a while because he has learned that from his senior that
Hmm.
this level of simplicity won't work. There needs to be more complex so that we can emulate the real life simulation, like what will
Yeah.
happen on silicon. And another thing is like reading the device manual. A lot of guys don't like read the design manual of their PDKs. I think that's
Yeah,
wrong.
yeah,
You
yeah,
have
yeah.
to. I
Yeah.
mean, you can do GM by ID, you can do whatever. I don't care.
Hmm.
But just by reading the design manual, you get an idea. Like someone says,
You
oh,
get in.
what's across the process, what variation? You can say, oh, according to the PDKs, around plus minus 30%. So quickly you can say that, right? Instead of, oh, I need to go back and do all my corner simulations and then see.
Yeah, yeah.
Right? So
And
those come in
also,
handy.
so when I was at university, like IIT Kanpur, so
Mhm.
one professor, he told me whenever you get a new technology, the first thing you should do is first read the PDK and also characterize and see if, it's
Yeah,
matching,
yeah,
right?
exactly, exactly. Yeah. That's,
So,
I think now with this new GMID thing going around, right? I think I recently shared someone's LDO design. I find it pretty good. Like, people are characterizing the nodes, people are characterizing the
hmm,
devices, and then they're using the GMID technique to design, which is like more proficient than Square Law or whatever, right?
yeah,
So it's good to do that. But it's also good to like, because in the industry, right, like people want answers like really quick now and then. And you
yeah,
have to be really intuitive, right? You have to recall, okay, you have to basically know your PDK
yeah, yeah,
so that you can understand even like all the parasitics, the even like MOS, or if you're using like BCD layers, like with some isolation, right?
hmm,
There are
hmm,
so
hmm.
many parasitic like PNPs and NPNs or
PM,
diodes, right?
hmm,
That during some event, some substrate injection or something or ground mounts can be forward biased. That is very bad for the circuit. You have to understand that. You can't just be like, oh man, like something happened in my circuit and right now I'm not being able to figure out.
hmm,
And trust me, most of it comes down to the device things.
hmm,
Like we
hmm.
look at the circuit, we can't, because when you look at the circuit, right, you're not actually understanding like what is happening inside, right? What the parasitics are doing. You're just seeing a four terminal device, or
Yeah,
if you have
yeah,
like deep isolation, there are 5 or 6 terminal device, and you're like, man, I've done all the biasing correctly. my NMOS body is tied to ground, my PMOS body is tied to VDDA. What can go wrong? There can't be no substrate injection. But at the end of the day, it also comes down how good you know your device. That's something that I
Correct.
was lacking, and now I'm trying to improve on that, obviously, so that I have
Mm-hmm.
a deeper understanding. Because there are some people who can quickly identify what's going wrong just by understanding the like how the like device is made. So
Correct.
I feel yeah, for analog designers, like you have to like slowly like learn, you know, almost everything. You have to be a jack of all, and maybe a
Yeah,
master of
yeah.
something, but you have to be a jack of all. If you
Mm-hmm.
yeah,
Correct.
so that is very important.
Yeah. So I have a design review in 2 days. In speaking to you, I think I got more motivated to make a better presentation now.
Yeah, I think so. Even like some of my colleagues, right? Like they are brilliant, like when it comes to design. But when it's come to presentation, right? Sometimes you can see like you're not really understanding what they
Mm-hmm.
are saying or so I
Yeah.
always give some kind of background about the circuit. I always have some kind of circuit description. I always
Mm-hmm.
have first I'll do some nominal simulation just to show them how the circuit works. I'll always, if I'm modifying a circuit, right, there is a option in your assembler to do like a config suite.
Config.
Yeah,
Yeah.
so you can create your own config view, your own modified schematic, and you can overlay. So you don't have to like run the simulation twice and then append the plots and stuff like that. You just do a config sim and you can see the difference in the circuit
Yeah.
performance, right?
Yeah.
So that's a very important feature I feel that one must use so that they just don't show
Okay.
the new circuit, they also show like this is the old circuit's performance and this is the drawback due to which that way
Mm-hmm.
people can relate more instead of like, oh, why he has
I
done that.
see.
Like, yeah, so all
Hmm.
these things matter and the more information you put is good because later you can refine. You can obviously show it to your manager and you can later refine what to show and what not to show. But it's
Mm-hmm.
always good to show better so that you can like later edit, right? Rather than
Yeah.
have
Yeah.
like less data
And
and
then
then it's like,
adding
oh,
later.
where is this, where is that? Yeah. And it's
I
also
see.
like like first I did not understand what are the critical parameters. I would just be like, okay, I'll do this, and this.
Hmm.
But you have to also have to look at like other designers, like someone you look up to maybe in the team, his design
Mm-hmm.
reviews, right? Someone who's doing a good job, and then
Hmm.
understand like what all he puts in his design review, what is the format. Also, I think for us it doesn't really matter how we present, but still like a good looking presentation with like good tables and good diagrams are very important.
Yeah. Yeah.
Especially like if I make some kind of system, right? I will write, okay, fine, this current mirrors are more prone to mismatch, which can be like, detrimental to our effect. This component is prone to variation, process variation.
Mm-hmm.
So this is something we need to look at or trim. This is more temperature dependent. This needs maybe PTAT biasing. That needs maybe CTAT biasing.
Mm-hmm. Got it.
It's a BJT cell, so it might go out of saturation. So all these things you can mark, in your schematic itself. Maybe not show it to the team, but you'll have a good reference when you're looking at it. That okay, this block needed this block needed that. So yeah, I
Yeah.
think that's
Yeah.
a very good way of kind of like looking at the circuit and yeah, if
Got
you're
it.
designing something for design reviews, those matter and how good your design reviews are will actually like help you grow more in your career.
Okay. Okay.
So
Great.
yeah.
Yeah, speaking to you, it feels like you're very passionate about circuits, and also it feels like you work really hard. So, just curious, I mean, it's a random question, but do you like by your own choice work on weekends? Like sometimes.
No, I don't work on weekends. I actually just work on weekdays. Maybe on weekends I'll study something or prepare something, or if like I said during tape out I'll do. But I have a lot of hobbies. I kind of do bodybuilding on the side. So most of my
I
time,
thought so.
like
Yeah.
yeah, so most of my time like after work goes in the gym, and I don't have a very happening social life. But yeah, I mean I'll try to learn as much as I can. Like recently, I've taken a low power course from UCSD, which is taught by
Hmm.
Professor Patrick Mercier. So I've been looking into that during the weekend sometimes. Sometimes I'll just like, watch some. So I started watching your podcast as well recently.
Oh,
I watched all the interviews that you have taken. So this kind of things, but not necessarily like, if it's
do you
not
have
required,
any
yeah.
suggestions for those? Like, I think there's a lot to improve on because I'm also new to these things, like YouTube and all.
No, no, no. I mean, see, I don't know your motive, but at least from what I'm seeing is like your motive is to like kind of inspire people, right?
Hmm.
And I feel that this is a very good platform. If this becomes successful, I'll be really happy because it will reach out to a lot of people, right? A lot of people from tier two, tier three universities don't even know like about the world of analog circuit. All they know is about software and whatever is we will
Yeah,
help them
yeah.
get a job, right? But I think this is a field where if you work hard enough, if you have some kind of guidance, right, that you are trying to provide, I think it will be really helpful for the upcoming generation to kind of take analog VLSI, like, consider it as a career option and not just
Mm-hmm.
like, let's say, the premier institute students. Because mostly
Mm-hmm.
if you see around you, even around me also, in analog VLSI, like students are mostly from like premium background in terms
Even
of
in my
education, right?
university, it might be surprising for you, I don't know, that in my batch, total, if you include everyone, there were about 130 or so electrical engineering students. And out of them, I guess around only 10 or so, or maybe 15, actually came into digital and analog both combined.
Yeah, it's
So
it's
it's a
more or less in analog, I guess.
in my
Analog
batch,
is
I think it's more in analog, but in the other
okay.
senior batches and even I guess my junior batch, they're more in
Yeah.
digital. Because in India, I think the job opportunities are more in digital.
Yeah, even here, like I
Yeah,
think,
in general. Yeah, yeah, sorry.
like even my like classmates and all, like they're all placed in like very good like Apple, Google, doing like verification, physical design, or
Hmm.
whatever like RTL design. So there's a temptation, obviously, right? Because
But Apple
they're
hires for
giving you
analog as well, right? Over there.
sorry.
Apple does hire for analog
Yeah,
as well.
Apple does hire for analog, but like they mostly hire for hardware engineering role, so you're not really
Oh.
sure what you're going to do. And so Apple mostly hires like big signal and
Mm-hmm. Yeah,
your
I see mixing.
serdes profile mostly. Even
Okay.
companies like AMD and Nvidia, power profile is lot less. And power profile you
Right.
need to have like very good, very good. Like they have this position called power architect, which is basically systems plus design. And
Mm-hmm.
you'll see like people with like 15 to 20 years experience go there,
Oh,
right?
okay.
General analog design you can go, but you're
Mm.
not sure what like team or what job, because so from some of my friends I've heard like who are working in Apple itself, like it's very partition what job you do. So you have to be like really careful. They have one of the toughest interviews though. They have like
Oh,
like
okay.
I haven't even, like applied to Apple yet. I'll apply in near future maybe someday. But I've heard from my friends like who have applied, they have a very rigorous selection
Okay, okay.
interview. So
Got it.
yeah,
Cool.
but yeah, I mean, it's good like what you are doing right now. I think I hope it reaches to more people and inspire more people to like kind of join analog.
Mm.
And I hope like more people will come to your stream and podcast
Yeah,
and
thanks,
share their
thanks.
experience. Cause even like I check LinkedIn, I check your page always. Oh, if there's someone new who is, because it's always good to listen to like other people's
Yeah,
perspective as well and what they are doing and how they are doing. Because I believe everyone approaches like very different
yeah,
even while you're working, right? Like on a circuit or beat anything.
yeah, yeah.
So yeah,
That's right.
I think this is a very good platform, and I find your passion to be like very good, Tejas, like,
Oh,
especially in analog. What you're doing in LinkedIn, and the informative post you're sharing, and I hope you share more like
mm-hmm.
lessons and tutorial videos. I think those are really good.
Yeah.
So yeah, keep on doing that.
Okay, thanks. Yeah. So, yeah, that was pretty much it from my side. Enjoyed it a lot. I got to learn a lot too. So,
Thank
thanks
you,
for your
Tejas.
time.
Yeah, I hope we stay in touch
Yeah,
and let me know if you need anything else. And obviously, it was great talking to you. And please keep on doing this. I feel at some point or the other, this will reach the right audience. And I hope the students in India, like, they get really inspired. And since you're bringing people from different perspective and background, right? I think like I hope today, like I can at least like inspire some people from tier 2 tier 3 university, because
definitely. I
that's where I
think
came from,
it was
right?
a great conversation.
Yeah. So thank you, Tejas,
Yeah,
and all the best for your design review.
yeah,
I'll catch
yeah,
you up on LinkedIn.
yeah.
All right, man, bye.